So remember the convention that we have after the encoder input is gonna be 2 times pi divided by 4026, right?
4096.
4096 is for the angle.
Yeah, because your encoder has that many counts per revolution.
Yeah, so you pretty much has to run the program, the plug.
Build it and run it and see what you get.
Yeah, so because we have 2 outputs, you can run it just for like a 5 or 4 seconds if you want to.
And there is the input signal on the right, which is the output from the relay, and the sine wave is the output from the motor. As we can see, it's oscillating.
Yeah, so too easy to calculate the A and PU and H, just save the output to workspace. Just go to MATLAB. It's gonna be easier. So if you see those 2 here, this is 1, the other 2. So in order to calculate H, H is gonna be 2H because the relay for us, the 2 peaks,
yeah,
it's gonna be -2 and +2, so it's gonna be 4.
Yeah.
So for H
is equals 2.
Yeah. And for PU, it's gonna be a complete sine wave.
The period of the complete square wave.
Yeah, so just you can write a code to do that or just do manually. I pretty much do manually. So go to, it's gonna be that one, right? Okay. Just double click on the plot. It's gonna show you the values -2 and +2. So if you can start from +2 complete square and end in +2, right? So it's gonna be 55 beginning with 2 and ending with 2. So from 55 to 270, you record those 2 numbers and then go to block time. So you just find 55 is going to be 0.054 and 270 is 0.269. So the difference between those 2 values, 0.269 minus 0.054 is 0.2150. It's gonna be PU. This is the period, 1 cycle, right?
Yeah.
It's gonna be 0.2150. So for 8, to find 8, so you go to this. This is the output from the motor. So you press this link. It's gonna show you, it's gonna give you the value, the peak value from X and Y. So if you see those values are changing every time, if you want to get the maximum value, so you go MATLAB and put max and the name of the output. It's gonna give you, so A is gonna be the max, right? The maximum value.
Yeah.
It's gonna be A. So it's equal to 0.1304. And so anything else? No.
No, so then you just
So,
calculate KCU, get
yeah.
the KPKI.
Using those values, you can calculate KCU. So
Just show them the code.
okay, after you have the three variables that you have, H, PU, and A, so you just go to MATLAB or do a code, write a code if you want to. So KCU is gonna be 4 times H, in this case is 2, divided by pi times A. So in this case we have 0.1304. Just this is the value for KCU. It's 19.5282. Okay. After you have the KCU, just go and get the formula from the Mechatronics website. So KP is gonna be 0.5 times KCU. It's 9.7641. So for KI, it's gonna be 1 divided by P divided by 2. So it's better just to put 2 divided by PU. So PU in our case is 0.2150. This is the value for K1, and for KD it's gonna be PU, in this case 0.2150 divided by 8. So this is the value for the KP, KD, and KI. So after that, you just go and make a plot. That is gonna look like that.
So this is the Simulink model of the controller now.
Yeah, and then this is gonna be KP. You just put KP here, or you can write a number if you want to. For KI or KD, just run the program.